All right, cool. Okay. All right. Yeah, should be good. Oh, yeah. So, how's it going, man?
I'm doing good. How about you?
Doing all right. Yeah. So, catch me up on everything. How did Facebook go?
Yeah, as I mentioned, first question, I have trouble just to understand the first part because it was random,
Uh
right?
huh.
He wanted me to return like the largest numbers of an array in a random manner.
Uh huh.
Uh, but I clarify this like with test cases, right? So I make sure to cover my ass with those test cases.
Okay.
Uh, and then while I was like walking through uh, an idea after I uh, showed like if was giving me like only no element, I should return -1. I make this convention with the interviewer,
Mhm.
and when I was walking through the idea, I assumed that I always can return like the first one, and then he said, "Oh, but it's random, so they have the same possibility."
Mhm.
And then I remake my idea, uh, and yeah, I wrote this just like a recipe, right,
Mhm.
for the interviewer to understand. And he said, "Well, sounds cool. You can go ahead with the code." And yeah, it was fine. Like during the code,
Okay.
I then like tested it to see if there was any bug, and he said, "Okay." And when I was testing, he said to me, "I think your code works great. So we can go ahead and just tell me few input examples that you consider for this."
Mhm.
And then I used like your technique of like consider a very edge case is not just
Mhm.
random test case, you know. So I said, well, I would test the edge case of no elements,
Mhm.
like only one element, right? And like a normal test case, and I will like generate an array with a million of inputs just to, for a matter of calculate the time. I said exactly this,
Okay. Okay.
and he
Okay.
said,
Wait. This is the first problem you did for the phone screen, the array
yeah,
of integers.
the first problem, yeah.
Okay. Okay. The test case, empty, one element, normal case, very large element. Test. Okay. Okay. It's not. The thing is that I think.
Uh,
So let me make sure I understand. Given an array of integer values, return the indexed largest element in a chosen random. I don't. Help me
mhm.
understand this one. Is 15652, and then you said 2 or 3. Why?
Two or three is the index, not the like the element. I should like to
Okay.
put more. Yeah,
So it's fine. It's fine. But why?
yeah.
Why is it? I see 6 and a 5. Shouldn't it just be 2? Because 6 is the largest element.
Oh, yeah. I meant. Let me just correct. I create a different example. This should be like instead of a six, you can consider that's a four. Yeah.
Okay. So
Imagine that.
okay. So but I still don't
Let me.
understand why would it be 2 or 3? Given return index largest element in a chosen random. Why is this index largest or random? I don't get it.
Hold up. Uh, yeah. So for example, five and five, right? There's two fives in this array.
Yes.
So I can return actually the index one or the index. I messed it up with the indexes.
Okay.
Or the index three. So instead of two is. Let me go in the same page as you.
Yeah, I'm on the problem sheet.
Shit. Yeah. Hold up. Um. Problem sheet. Okay, there we go. So yeah, it should be one or three. So
Okay.
the index.
Okay.
And yeah, I just reversed through the array and like store the elements according to the largest. And yeah, those basically this. And then I
Uh,
choose a index from this choosing largest elements random, you know, so they can have the same probability to appear in a result.
okay, let's see.
Basically, that was it. Yeah.
But you picked all the largest ones that you've seen so far.
No, no. Let me. The thing is, I try in this max global to have, like, to keep track of the largest elements. So for example, imagine I'm in 1. 1 is the first biggest element.
Okay.
Then I'll go to 4.
Okay, 4 is not the
Four-
biggest element.
Now is the biggest element. So I will reset my array. So I will just, it's gonna only consider 4. Then 5 is the new largest. So I'm just gonna consider 5 and reset the largest indexes, right? And just consider the index of 5. And then, yeah, 6 is the largest, so I'll just consider the 6. That's the logic.
Okay,
And,
I see.
yeah, basically that was it.
Why didn't you just do two?
And-
I would have done it as 2 passes. 1 to find the largest element, 2 to find all instances of it. But this works fine. As long as you acknowledge the trade-offs.
What will be like the trade-off? I was not aware about this while interviewing.
So you basically end up creating our lists over and over and over again, right?
Mm-hmm.
So you pay a penalty.
Oh yeah.
Yeah, that's it, right? So if I do it, I mean, in the end, in theory, you end up, you can do this in 1 pass, and you're correct. Your answer's correct. It's just that you're constantly creating new lists and orphaning old ones. So it's like, yeah, you're allocating, deallocating memory, but I mean, in this end, it should come out to be the same, because you will end up like having a array of those indexes. So this is fine. This is fine. I understand where
I acknowledge that now.
It's fine. I think it's a little subtle explanation, but it's not really that necessary either. I definitely would have just gone with the 2-pass approach first, and then tried to just figure out how to do it in 1 pass, and then probably gotten. Yeah, I think getting your answer would definitely. Yeah, I don't have any complaints here.
All right,
Okay,
but
so
yeah, I didn't acknowledge this while interviewing. Yeah.
okay, that's fine. And then I would say. So you said empty 1 space and very large element.
Yeah, I said this in like a normal one.
So when I look at your code, right? 1 is
Yeah.
iterating through the length of the array. The length of the array doesn't matter if it's very long, to be honest.
Okay.
I mean, technically you could run into some weird memory issues out of bounds. But that's definitely something that you could, if you run into like an array that's really really big, and that you have multiple repeated indices. So to me, when I see this, like, okay, well, if the loop is nothing special, but the length of the array is, right? So I understand this, but then there has to be a point to the very long array. Like, why do I care? Because even though as long as we store an array in memory, we can iterate through it, right? That's fine. So there's nothing special here. So then this is the first thing I would say. I look at this if and else if statement, right? I would want to pick a array that has a lot of changes. So like an increasing array, that'd be 1. Or 1 with repeated numbers, that would be 1. So I think you missed the point.
That last one I consider. Yeah, I just don't put on here. But I said, okay, and if like while you're talking about space complexity, I said we can have an array with all repeated elements, so we have to store like all of the elements of the input. So yeah, but not like we're giving the examples. Just I acknowledge this last option only in the space complexity.
Okay, yeah, it's really important, because like notice like how I'm breaking down the code. I'm looking at the if statements and just using that as my litmus test. So then if this happens, then I need to change and append the current array. Otherwise, I need to have repeated elements. So I'll do a repeated element, an increasing array, and then an increasing array with 2. So like it'd be like something like 5 5 5 5 and then 6 6 6 6 just and 1 and 6 6 6 6 just to be like, complete. That's basically that's how I would think about it. And then I would have that nuanced discussion of like, oh, what do we run memory out of bounds and shit. But you notice like how I literally just went through the code and said, hey, this is what can happen at each of these lines.
Yeah.
So
one question about this. The reason why you were considering this is like to, as you mentioned, like to, if it's gonna run out of bounds, right?
Yeah.
Okay.
Not only out of bounds, it's really out of memory.
I said I think was not the appropriate argument. I said just for a matter of calculating the time that this code is gonna run. Yeah.
Yeah, and your limitation is actually this array and then largest indices. So this like this is another edge case, but I was like, yeah, at least you thought about the edge cases, but you really need to be a little bit more methodic about testing, in the sense that okay, what can go wrong at these lines of codes and what do they imply? So like for instance, this branching factor, right? I would need to make sure I have a test case that covers this branch and a test case that covers this branch. So that's why I have increasing array and then increase it and then elements an array with a bunch of repeating elements. So this I think like if you tried looking at things like that, it'll be a lot easier.
Look into the code, right, and trying to. Yeah. That makes sense.
Yeah.
Okay.
It's a little bit nuanced, but it's not that bad. Although depending on who you're talking to, you might want to they might fight back, like, hey, it shouldn't be reliant on the underlying implementation of code. In which case, you just bring in the exact same idea, you know. Instead of applying it to like the code that you've written, just apply it to like the idea. But then again, a code is the implementation of an idea, so that gets into a very hairy discussion. But yeah, it's hard for me to like describe what exactly I'm saying. But the bottom line is, don't make it like use the code as like a guide for like the branching factors that you're using. But really, ultimately, if you have a solid idea of what you're doing, you should understand like this is a branch in my idea. Where can go right? What can go wrong?
Okay.
There's just a more explicit
take
version of
notes
that.
on this.
Yeah. This just what I'm saying is just like look at the code as a more explicit version of this. Okay.
Yeah, because like just pointed out here, from like this week, I was trying to, as you mentioned, like to cover my ass with tests.
Yes.
I was going, I'd say like, I was trying no elements and like invalid inputs, right?
Good.
And I was trying to see like how these invalid inputs can be. And yeah, I was not actually, because I didn't have the code yet. So
that's fine.
I was trying to create like this first examples. You will see, I guess, on the practice sheet, on the problem sheet.
It's fine to not have the code yet. In fact, let's pretend that you did have this code, right? So you know that you described your algorithm that you would just iterate through, and then if you had a bigger element, you would record it and record all following instances of it until you got another bigger element, right? Yep. So within that idea, you can already say, hey, well, there's one action you're taking, a bigger element, right? So the first thing you should think is, okay, well, do I have a test case that covers that? And then within that statement, you notice I said all other instances of that bigger element until we get another bigger element, right? So then I got to make the second test case would be making sure that I record the repeats.
Okay, that makes sense.
Yeah. So notice like every time you take an action, that should be tested. So what can go wrong with this? Like do I really have my ass covered when I make this particular decision? It's not the overall problem. It's not just that. Like, that's one part to it. But it's also these individual factors that you have. So like for instance, if there's a code with like 50,000 branches versus 5 branches, right? 50,000 branches implies you need to write 50,000 tests at least to cover each of the branches. But if you have a code that has like 3 or 5 branches, you cover each of these. You cover each of the 5 branches, you're good.
Okay. So like I'll try to think in this idea of branches.
Yeah.
It's easier.
Maybe branches or like or choices. Like let's say you're walking through the algorithm. You have a choice between choice A of the algorithm for one path and choice B, right? In this case, do I want to replace the maximum element or not? Boom. That's your test case right there.
Yeah.
Is every single choice that I can make that I could potentially like go like veer off into like wherever. You try thinking of a test case. That's really what I'm trying to get at here. All right, question 2.
Okay.
Given a binary tree, create a doubly linked list and placed. Okay. So
for just one question before the other question.
Yeah.
When I was implementing, like in the before the return, I have to index choose here. Yes. I have to be honest with you. I didn't remember like the notation to. I just study this because it's something that can appear in an interview. Like to choose a random. I didn't remember random in Python. And I said to him, okay, I'm going to implement this function. and then I will implement it later. And then he even said, I got lucky, but I don't want to count with lucky. He said, okay, there's no need for implement this function because it's too trivial and all the programming languages have a random notation. Yeah, anyways, just to point it out here.
That's fine. I would say I don't even remember the system time millis random whatever for Java, but as long you already understand that it's not the thing that's most important to the problem. Remember what we talked about objectives? Like, what is the objective of the problem? Like, it's being able to at least come up with this, right? Coming up with a random number generator is not the objective, and it's very trivial because, like you said, this is going to be available in almost any programming language. So, keeping your eye on what's important.
Gotcha.
Yeah, that's it. And I mean, like, worst comes to worst, you can always come back to it and try figuring it out yourself later, but whatever. Yeah. So, given a binary tree, create a doubly linked list in place. Okay, I understand what he's trying to do here. How would I change references for this since the node only left and right has child references? Yeah, so basically it's just a glorified LVR traversal. So this would just be L,
sounds...
and then V, and then R.
LVR.
Do you understand why I thought this?
No.
Let me highlight it then.
Okay.
Do you see now?
No, yeah. This nuance I got. Like,
okay.
After a lot of struggle, I got like, okay, for each node I take the leftmost, but I didn't like remember of LVR, but it's definitely LVR. Yeah.
Okay, but yeah, this like instantly clicks with me because one, like, tree problems always involve some kind of traversal. So there's that association right there. Like, okay, what kind of traversal is this possibly like something I'm looking at? And so it goes back to like recognizing your patterns. Anyway, that's Rex. First thing I said was maybe use an extra array to know the parents, and immediately interrupted ask about space complexity. Fine. Order a number of nodes in the tree. Yep, he asked for a solution that would use less space. Yeah, I think you should have I would have said you should have recognized the LVR traversal, but it seems like eventually you get kind of figured he gave you a hint like, hey, think of it as a traversal.
Yeah. No. Yeah. The hint was exactly this one. He said, okay, imagine that we are on node 1, right? What do you want it to consider to be the left reference and the right? And in this time, okay, I should consider the leftmost node of the right tree and the rightmost node of the left tree. And now, that's it. And I applied this to the others, and I said, I just need to manage to don't lose the references, and this should be the main idea of the code.
Okay.
And he said, okay, that's pretty much it. But I think we're running out of time, so yeah.
Yeah, it depends on how much time you took for that. Honestly, you should have probably instantly thought of the LVR traversal, so that kind of worries me. But if he says like, hey, look at that, and like, oh, and you were able to execute on it, I think it's okay, but it's not the greatest thing. But yeah, you notice, like, again, I think I mentioned this in the past, and maybe offhand, is that you're only like with certain data structures and algorithms, you're given certain choices, right, and a limited number of them. So what you described isn't necessarily bad. Like, you at least came with a naive solution. That's something, right? But then it's like for trees, you're almost always forced into some kind of traversal anyway, because you need to get all the elements. So, and now, like, even if we walk through this, is that okay? Well, I am looking through all the number nodes of the tree. My inefficiency is that I'm looking through the nodes twice, once to populate, once to populate the array. And so, how do I do this in one pass? That's a natural question. So now I would look at, okay, what are all the different ways I can traverse the tree, and do they match up, and then boom. So it all roads lead to Rome. It's fine though.
Yeah.
Okay. That's basically it. I would say, depending on how you did, it could range from anywhere from like I would say 5 to 7 out of 10. Yeah, 4 in the worst case, but you probably passed. I want to say but I mean, then again, there's always like small things that you might have missed in your self-reporting that other people might pick up, but it looks like it's okay.
But one thing we should consider as well, is because like the result of this first phone screen is going to be compound with the online assessment. So it's like I was worried about this because from my perspective, I considered that I was better on the phone screen than in the online assessment.
Yeah.
And then the last time, like in October, my last interview with Facebook, the recruiter like reached out to me like after the first interview in 1 day with a rejection. Now she didn't like. They even said like how much time they're gonna reach back. But
Okay,
anyways,
that's fine.
let's hope for the
hear
best
back.
and
Yeah,
prepare for Microsoft.
yeah, I'm just giving you my assessment. We'll hear back when we do. But yeah,
For sure.
overall, I would say the performance is average. Like it wasn't stellar out of the park, but it's average. Like you need a hint. Okay, fine, whatever. But we'll see. Depends. I guess at that point it'll be depending on like the people you're up against. Like if they found people better, then you might not get it. But it was short on time. We do what we can. All right, let's look at your problem sheets.
Okay.
Yeah, because at this point,
Same.
mostly it's about fixing mistakes. Once I feel like you've fixed enough mistakes, we can do more coding interviews. But I'd rather keep fixing your mistakes. Okay, let's see. Which problem should I start off with? Let me look at your.
I think with the ones I struggle the most. Okay,
Yeah,
from
let me see your practice diary. I'm gonna look at a practice diary too.
okay, I think there's one.
Yes.
Just let me hear which one is the best because I rather focus on the ones I struggle the most. Hold up. Oh yeah. One point about my practice. I had to confess I having difficulty while deriving the time and space complexity, or
Okay.
some recursive solutions.
Yeah, I kind of figured.
Because, yeah, or I'd say I having like a hard time with this.
Okay, but
I have like kind of a sense about what's gonna be like 2 to the power of n, but like there are some cases that it varies. Yeah, accordingly.
Okay.
But I think the question of okay, generate string match parentheses. I think there's only one nuance I missed from API. Ben, I think there's no preferred question. You can go whatever you want to.
Okay, let's see. I will say I want to pick one that you thought was a clone. So let's do this one. Generate palindromic decompositions.
That was the last actually.
Yeah, I'm curious about this one. Do you have the?
I send you on Discord like the link for the practice.
Oh, practice sheet
sheet
M5?
M5.
Got it. So let's see. Okay, so I see compute valid IP address. Yeah, let me copy paste. Well, yeah.
One thing I'm doing is like when as you mentioned, when some part of my code is not exactly like API,
Yeah.
I am like trying, as you mentioned, like to run the API and like go line by line and see the nuance I could get, in order to be exactly the same.
Yeah.
Because sometimes it's like 80% the same, but one nuance that they had was much more easier to read or much more succinct.
Right. So in those cases, it's like, okay, well, what do I need to do to get there? So yeah, running it line by line is definitely helpful. Anyway, let's read the problem. The string is said to be palindromic. It reads backwards, same backwards and forwards. Okay, fine. A decomposition of a string is a set of strings whose concatenation is a string. Okay. 6116. Okay, 61 is palindromic and decomposes into these 3 strings. Okay, sure. Compute all palindromic decompositions of a string. For example, if a string is 02441, then decomposition 0204445 1 is palindromic. Okay.
Yeah, all the decompositions should be palindromic, not only one. All the, yeah.
Got it. So so when you decompose a string, make sure each one of those strings themselves are palindromes.
Yeah.
Okay, let's see. So you do an example here. Yes, you understand. You understand. You understand. Okay, what happens if it's empty? Your base case is yeah. Is okay. Sure. Now you approach generate all the possible decompositions in different sizes and save them possibilities. Then verify those possibilities are that have all its partitions as palindrome is valid. So I'm thinking you're basically saying for all of the different all possibilities, make sure all its partitions that you split it up to is a palindrome. Fine. Store and then store the valid results. Fine. Too much time and space. Yep. Better approach. Instead of generating the positive valid, we can prune our possibilities by valid decomposition. Okay, so you're gonna do 6, 6, 1, 6, 1, 1. So what exactly is happening here? Because I see you're adding 1 element to the end, 2 elements to the end. 3.
No. Let me try to explain.
Yes.
So first, there's like the given string, and then I just add 1, right?
Okay.
Before verify that that's a palindrome.
Cool.
In the second level of the tree, on the left-hand side, I was trying to add only 1 more that is a palindrome. Then I go just in a depth first search, and then I add 1 more, right? So the first possibility is to decompose element by element. So one element be one string separately. And this is going to be like a valid case because each element, each number is a palindrome. And then I'll backtrack, on like one level before the last. And then I'll try to, instead of add 1 to the last, I was going to add like 2,
Okay, I see.
Yeah, actually on the second level, down below the 6.
Okay.
That was it. But before I will add into my possibility, I will verify that if it's a palindrome or not.
Okay, perfect.
Because so I don't kind of compute possibilities that doesn't go anywhere.
Okay, I understand. You're basically trying everything possible combination, but what you're doing is you basically at each level you just add numbers to the next number you're adding to the list until that element is no longer a palindrome.
Yes.
Okay.
Yes. And if it's not a palindrome, I kind of prune the branch of the tree, the possibility tree.
Okay. And if it's a palindrome, then you append a recurse. Otherwise, exit the loop. But yeah, you should write out otherwise exit here, but it's fine. It'll be skipped anyway. Just for the sake of it, it's fine. Okay. So, yeah. So you're testing that. Good. Okay. So when you're testing this, remember what I said before about like the choices that you can make at each and every single branch? I want you to try applying that here. Look at your idea that you got going, and I want you to come up with what are the general test cases? What are the general idea behind these test cases that you want to have?
Basically, from my understanding, if it's palindrome or not palindrome, this is going to be the condition so I can continue or not. So I managed to take an example which I can have a decomposition that is not a palindrome, that is 61 here, or 611, right? And the other, I have like the 15, that's not a palindrome, and the 51 as well. So yeah, that was what I was trying to do here.
Okay.
I tried to generate those 2 examples based on these conditions. Is there anything else that I can improve while doing those examples?
I think that's pretty much right. You're basically at each branch, you're grabbing an element, and then and then building up your chunk, and then just based on whether or not that chunk is palindromic. So basically, you would need to test a sophisticated example that would, that you can recurse into multiple times and make sure that you pop out of. That's it. So I think the simple examples are okay. I'm not a fan of what's called doing 1, 2, and then 1. I think it's too simplistic, but it doesn't really add too much in this case. So it's just like I'm saying that your testing is fine. It's just I might have done a little bit more complete, like the original, like maybe not the original, but like the 024 one. But I think that otherwise these tests that you're doing are basically representative of what you're trying to do here, so it's fine. Does that make sense? It's like the test's a little bit short, but it's fine in this particular case.
Got it.
Yeah.
Well, but I mean, like it's fine. But do you have anything to add? I mean, to be like, I don't know. I don't want to.
No,
margin for error.
not really. The thing is that it's hard because there's this one I think I've mentioned before. There's like a sense of what's it called, instinct to this, right? So
Instinct,
so based on
mentioned.
like previously testing other problems in the past, I'm like thinking, this is a little light. That's my instinct going off, right? But then when I look at it, I'm looking at it based on like, okay, does this actually cover all our ass on every single possible situation? And it pretty much does, because there's no difference between like growing a chunk from 1, 1, 2, 3, to like just using 1, 2, because there's no difference between testing 5, 1, 8 versus 5, 5, 8.
Yeah.
Yeah,
Because the choices are gonna make in each like level. Yeah, I understand your point.
Yeah. So it's a little bit of it's something I probably would have thrown in there, but it's like it's not the end of the world. It's not like adding one more element is not that bad, but it's something that I probably would test for, because effectively all that does is just test to make sure that you are actually appending.
Gotcha.
So
Gotcha.
it's
Makes
a small
sense.
thing. So anyway, let me look at the books thing here. 293, got it. Cool. So let's compare your answer to the books. Let's see what you get here. Okay, so yeah, I do like this. I like that you're doing a call, that you're testing the code like that. So let's see.
Oh, actually, for this one, I was going to test before our coaching session, like compared to the book line by line. But yeah, we have this kind of delayed.
That's
But
fine.
anyways, was the last one. But if you go in the others.
Yeah, I'm really looking at it right now, actually.
No, but I think it's kind of the same. They just implement it in a different way.
It looks like it. Let me just go line by line. Okay. Yeah, so they have the offset here is palindromic. Length of decomposition 0. Okay. Yeah, you just have that early check. That's it. It's pretty much the same except for this one.
Yeah.
And the question now is, do you feel it's unnecessary code? But then the question is, do you feel that the thing is that decomposition chunk will never be 0. So this is unnecessary.
No, it will. While I was testing, I verified a case where, for example, imagine that like the given index is 0, right? And like my first index in the for loop is going to be 0. So I would generate a chunk like this,
Got
like
it.
an empty.
Yeah, good catch. Okay,
So
good catch. Index.
That cannot be considered.
Okay.
Yeah.
If index b is equal to index, then you end up with a chunk of 0. Yeah, that's fine. Although personally, I don't. This is a small nitpick. I think your answer is correct, right? But the reason why I would just say index plus 1, if that's the only thing, right? Because that's the
Yeah, the
only case
book
that you
did
can run
this. The book did this exactly.
Yeah. And it's like it's not again, it's not like killer end of the world, but it's like understanding why they do it, and it's because you don't want to have a bunch of extra chunks or checks inside. You would, if anything, you want to reduce the amount of if statements and if checks that you do in here, and just just keep it simple up here. That's it. It's just eliminating one extra line of code by just having a plus 1. Other than that, it's fine.
Yeah, because I even acknowledge this in the end of the question, because I think to myself, well, actually for all the for loops I will have like a unnecessary iteration, So I didn't thought about like, okay, let's start one more. I don't know, maybe. I don't know.
It's fine. It's fine.
yeah.
It's definitely something worth chewing over and understanding what happened there, but otherwise it's okay. Yeah. So let me ask you, like, before we go to the next problem, how'd you feel about like just having to constantly test and just go through that checklist?
Well, I feel that since I was more, what's the word? Like obsessive with my tests,
Yeah.
I was able to, like, in different questions, see that my solution would not work while testing, So I went back to my idea. So it made me like safeguard in all the ways and cover my ass.
Good.
to don't mess up in the final code, you know.
Mm-hmm.
And even if in the final code there's a bug, I managed to fix this, you know. So it's like layers of of proof, you know.
Yeah, it's protection.
Basically, I felt that. Yeah.
It's like going to the bedroom without a condom, like what you were doing last time. That's the best way I can describe it. and we call, and you know, like it's like we call it shooting up the club. And you understand why. But anyway, yeah, the point I'm trying to make here is that it might feel like it's taking a while, but I want to train this muscle of testing, because eventually what will happen is that all these like testing that you're doing and writing it out, it will be automatic in your head. You should be able to like test it in your head and just understand at some point, oh yeah, this is what can happen, what can go right, what can go wrong. But if you keep like up this level of like testing, and then slowly try to turn it into instinct, like it will click one day and say, hey, wait a minute, I already know all the possible test cases it's going to run into. And remember, and what I said before, like, oh, it's going to turn, it's like chewing dry chicken. You'll know when that happens immediately.
Yeah.
So
Sure.
So we want to get to that point where you feel like you're chewing dry chicken. So until then, I want you to keep doing the tests, and try to predict ahead of time, like what these tests are going to look like. Does that make sense?
Okay.
So yeah, just try to predict these tests, like what tests you're going to need.
That makes sense.
Because like when you notice, like when I'm doing the problem, I'm like instantly reading it. I'm like, oh, this is what can go wrong, 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 wrong. We want to get you to that point.
Like to create this instinct.
Yes.
Okay.
Yes. So a big part of that is going to be like predicting. So now that like now you're doing this, the next step is to try and predict like what tests you need before you think about it. Try to get like a hypothesis and then try to match that up as well. It's a small thing, but it'll help train your instinct a lot faster.
Okay. It's just like the other habits.
Yes. I see that it took you 55 minutes, but I assume that's mostly the testing.
Yeah, mostly just testing. I think the same. Yeah.
Okay. I still think that you can get this down to sub 30, even with the testing.
Yeah, I think the same because like the tests. Yeah, I think the same.
Yeah.
Most of these questions that took more than 30 minutes was basically because of like the 3 layers of tests I was doing.
Yeah.
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 Creating this instinct.
Yeah, I mean this is just training your testing muscle right now, so I'm fine with that.
Yeah.
Let's do one. Let me look at another problem here. To generate subsets of size k, 1, 2, 1, 3, 1, 4, 1, 5, 2, 3.
Oh, there's only one. I don't know, like the generate string match parentheses. So I created the answer based on like the last kind of nuance you gave me.
Yeah.
But I kind of, while you're creating, I didn't look to the book in advance. I was like creating from my head.
Sure.
I thought about a better solution, you know.
Okay.
But if you see, it took me like it took 1 hour basically.
Okay.
I was like, I'd say that 90% on the idea that the book came, but I was not figuring out where I should store like the possibility, you know, the valid possibility.
Okay.
Yeah, the only one that I got like, there are only the ones I missed to a perfect
That's
solution,
fine.
you know.
That's fine. Well, we can look at that afterwards. I'm very curious to see what you mean by a better solution anyway. So let's look at this one. Generate all subsets of size k. That's fine. Not possible to generate subset. Yes. Okay. 1, 2, 3. Only one possible subset. Yes. Returns empty set. Okay. 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 Fine. You covered the cases. Now you're walking through to try and actually generate it. So you're gonna take one element and then pen. Yep. Okay. 2, 3, 4, 5. Okay, yeah, so it's just the depth of your tree that matters. Okay. 1, 2, 1, 3, 1, 2, 3, 1, 2. Okay, yeah, I understand exactly what you're doing here. Generate an array with elements. So
With and without, like the possibility, the current element actually.
for each element, create a sublist adding the element. I mean, you don't necessarily need to generate the array. You can just loop, I think.
Yeah, like on the solution I didn't generate.
Yeah, so it's
I acknowledge this.
that's fine. That's fine. In each case, the subset in the size k, we say that there is a possibility. Backtrack to any combinations. Okay. Yeah, that's fine. I understand what you're doing here. You just append. Like, the examples help a lot. The length subset. Yeah, this should. I think this pretty. This should be pretty much what the book does. Maybe they might prune a little bit of these edge cases. But other than that, yeah, I'm very curious. Like, I don't mind this because it does limit what you need to focus on. But I'm like a more elegant solution might be able to handle this case on its own. But
yeah, I acknowledge this. The book solution, they just instead of because like talking about the solution, I kind of modified this while I was testing because I acknowledge that the way I was doing was not cover like all the answer. And because of that, I consider this max. But this max is only going to be on the first check. And the book is doing like in a more succinct way.
Yeah, let's see what the book does.
It's hard to put in words what I try to
okay,
do.
that's fine. Let's see.
Yeah. Okay.
It's what's it called? The problem is
Hold up.
Is it? Oh, generate all subsets of size k, right? Or generate the power.
Yeah.
Generate the subset of size. Cool. 16.5. Great.
So like generate all subsets of size k.
Yeah. So yeah, the instinct here is partial. Okay. No. They. Okay. So there's your helper function. Other than that. Yeah, they're much more succinct with it, but let's see if you still match up here.
I can send you the Python.
No, I have the Java version. I'm pretty good.
Oh yeah, you mentioned you're in Java.
Okay, so you have a helper function. Your base case is if it's equal to k, you can do that. That's fine. Copy if index is greater than n. Return. I don't think you'll ever have a. I get why this check exists, but I don't think it's necessary for me. So, where's your backtrack? Oh, I see. You're appending the list and returning a copy of the list here. I'm very curious. I actually don't know how. What's it called? Okay, and then you also have like this here.
Yeah, if I want, I can walk through the test I did.
It's like having this. Like
that's unnecessary. I figure out later.
Yeah, I think you overcomplicate it. Like I don't know why you need max of index and index b.
I can explain you because if you go on the tests.
Sure.
Just below this solution. Like for example, I'll be iterating through the first index, and on the first index, then I'll go to the second, and then I'll try the third, and then the fourth.
Wait, which example are you looking at?
Like the test case down below this.
Oh, okay, below it, okay.
Solution. Yeah. Test 1, k equal to 3, and then n equal to 4. So yeah, that's what I was trying to do. So for example, I'll be considered 1,
Okay.
and then like it's because it's recursive. I deleted it, but this will be something like 2, right? Actually 2, and like the index I will pass here is to the other call will be for this one it's gonna be 2. Hold up. Yeah, I just managed to see. That was actually one of the questions. I created one solution, and then while you're testing, I figured out that my solution would not work, and I did this modification here. Because, for example, I'm gonna have the index B, right, from the for loop, and the index that came from the recursion.
Okay, I see.
So I don't have to test like cases that I already tested.
So
I just
I see where you're going with this. Why don't you just do index plus one?
Again, like the same thing. I didn't catch this.
Yeah, I mean, I just make it life so much simpler. I get like this. Okay, now I understand like where this is coming from. It's just like a patch and pray. But then remember what I said before? I'd rather not deal with it inside the loop. I'd rather just like cut it off at the beginning. So
yeah, I acknowledge that I was like, yeah, I need to adapt to my solution. And then, oh, that's Edward will know, like, because that's a patch and pray kind of thing.
Yeah, exactly. If you're patching and praying, something's wrong. But yeah, like also like this to me, this also screams the exact same mistake as the other problem that I did. So that you did. So I would definitely make this a point to never make this again, especially when you're iterating through indexes. So like next time you iterate through arrays and strings, like just yeah, I'd say just this. This is like the one to remember. Although I also want to be a little bit careful about this one. I don't know how Python does like the array or list.
Oh, that's correct. When you do like a possibility plus, it's gonna add in an array. So yeah.
Okay, is it a clone or is it like a reference?
That's something like this. And if we have an array 1, 2, 3, right? And we have a 4. This will be something like 1, 2, 3, 4, like with a clone.
Okay, but then so this will create. Is this a clone? Oh, this is a clone, or is this a reference to the original array, or how does this work?
Underlying.
How does this work? Yeah.
Yeah, under the hood. I don't know exactly.
You should. The reason why is because if it is just going to modify the original array, then you do need to implement a backtrack. If it's a clone, then I understand. That's fine, but you have to you have to understand like what the heck is going on underneath the hood here.
Okay. Yeah. Okay. Because other parts of the book did this, and I just mock this.
I get like they do it, but then it also there's a danger to copying things without understanding this.
Yeah. No, I'll understand this.
Because I'm pretty sure like okay, well, because sometimes these programmers and engineers like sometimes they're not privy to the nuances of the language themselves. So you need to be able to defend it. So this is like something. The reason why I bring this up is also because like it didn't work with our plan, right? Our plan basically said, hey, we need a backtrack. But I don't see a backtrack. So, but I see this. So, like, does this implement the backtrack as well? And the only way this could implement the backtrack is if it did a full-on clone and copy of the original list.
Yeah, that makes sense.
So, you kind of see, like, how I just had that checklist, right? Or...
Yeah, you can, like, if my interview was going well, you can just kill me with this one little detail.
I literally... dude, that's why I'm an asshole interviewer. I can find some detail and kill people with it. If you most people don't know.
Yeah, one time a friend of mine was solving a question that was only to use a hash map, right?
Yeah.
And the interviewer was asking a lot of things about the underlying things of the hash map. Yeah. And he just was rejected on the interview. The question was like perfect, but he didn't like knew how to answer all of those questions about hash map and was just rejected. Anyways.
Yeah, I'm that. Believe me, I'm that type of interviewer.
Okay, so you're pretty.
It's like if you're using something, you better understand why you're using it and why it works. It's like if you're gonna use a power drill, you better understand like, hey, this thing can probably kill you if you put it to your fucking arm,
Yeah.
So it's like that. It's like I have to understand. I have to make sure if I'm gonna trust you with a power tool, I better make sure that you don't kill yourself with it.
Yeah, that makes sense. So I'll be aware with this as well.
Yeah. So all right, let's see what you wrote for the write-up. Went to now create output. So this is the subsets of size K.
Yeah, 174. Row 174.
Yeah. The brute force.
I haven't acknowledged the brute force. I just went to the most optimal.
Okay, that's fine. That's fine. Because it's pretty easy to just go straight there. Because it's very obvious. Like I said, if it's very obvious to you, you can listen to your instincts. Okay. And then I want you to and they give you the order and choose K. So I think So for a lot of these, I want you to start doing the time complexity.
All right. Yeah, as I mentioned, for those that are exponential, kind of they're different. So I didn't have like the framework to calculate this, but I will study this as well.
Yeah. So really understand like why you came up with the wrong solution, how they came up with theirs. There's not much I could say on this other than that. Yeah. Okay. Let's see. Let's do. All right. Okay, so then since we're looking at mistake, is there another problem that you want me to look at or in particular?
Hold up, let me just take a look here. Um, it's okay for you, like the generate permutations, because API came with them. Yeah, I acknowledge what they did here. Like, actually, I was just able to create the naive approach, not
Okay.
the optimal for this one.
So you weren't able to come up with the
And-
optimal. Let's see why.
Yeah, and like I just put the optimal there, but was basically I was reading the solution of API and then I just created basically the same, but it doesn't count.
Yeah.
Yeah.
You have to understand like what's the step by step that they took and what's the step by step you took.
Yeah. Basically, they were, instead of considering like options that would not make any difference, they are just considering like options that will be valid. So they're kind of going in a more, how to say, in a path that will not generate repeated choices. So by shifting the elements, So for example, if I'm in the index 0, I will shift with the elements that are all the elements ahead of the 0, 1 and 2, given the size is 3,
it.
right?
Uh-huh.
And then if I'm the index 1, I will just make a shift with the index 2, and so on,
Uh-huh.
I didn't thought about this nuance of doesn't do repeated work.
Yep.
That was basically this.
Okay, let me actually see like let me fully understand the problem. 2357, 2375. Yeah.
It's simple. It's to generate all the permutations for a given string. But yeah, a string
Yeah.
of numbers. Yeah.
That's fine. This one. Yeah, it just means that optimization. I understand why you would miss it. It's a little bit nuanced. Yeah. So you take 2, then you take 3, 2, 3, 2, 4, 3, 2, 3, 3. Yeah.
Mine was like not near to optimal.
Yeah. I'm trying to think if it's even material. That's the thing. I understand why. Inefficient iterating through elements that have already been computed. But in permutations, the ordering matters. So I don't know if that really is right. So use the current index hash set, append current element.
What do you mention that matters? I didn't catch this.
The ordering should matter. Yeah,
Okay.
yeah. This is pruning. This is about pruning. But I mean, this is fine. Yeah. And then you also need to evict from the current used index when you set. Yeah.
My solution.
You call that.
That was, I think, the worst question because I was using a lot of structures to keep track of what I used in terms of indexes and like elements.
Yeah.
Yeah.
No, I mean it happens. The swapping thing is actually a little bit nuanced to me as well. Like to me, it's not really obvious as to why it would work. I don't blame you for missing that.
I think Grokking solution, even you said to me, don't use Grokking anymore, but Grokking solution is kind of more intuitive. I will show you if you want.
I'm gonna say like let's not focus on Grokking. Let's stick with our lane.
Okay.
Yeah, the swapping thing is not very obvious to me either. I understand why it works, but like being able to figure that one out on the spot would have been kind of hard. But I mean, it's a good useful trick.
Yeah, pretty much.
It's fine. I have no problem with you messing up on this one, but because you have the basic idea down.
Uh-huh.
But this is a useful trick to memorize, I would say.
For sure.
Okay.
For sure it is.
Okay. Other than that, I think you're doing much better with the testing, so that's very good. And it's definitely showing in your answers as well. You're not making like any boneheaded errors. So it's fine.
Yeah.
The next step is to really make sure that our instinct is trained and that we want to make sure that our what's it called the
Chewing the chicken, right?
yeah chewing the chicken. We want to get to the point where we feel like it. It's like, oh God, why am I doing this? But that means that that means your instinct is correct and that you understand that what tests you need to be done. So just keep at it, and eventually that day will come. But for now, what I want you to do is really to predict what tests you will need based off of reading the problem. See if you're right. So this is a small step before you even do the problem. Try it just as an exercise. So let me put this in your doc. So
Okay.
it's a small thing before you just try this to train your instinct and then see if you're right. You're right.
If not, go back to the same, right?
Yeah, and if you're wrong about your prediction, figure it out in analysis. What was the case you missed? Is there a heuristic that you can use to I say to recognize it earlier? That's the first thing. Then after that, I also want you to get better at runtime.
Recognizing runtime. Okay.
Yeah.
Do you have any suggestion of like where I can? I think the book have a section of only about runtime.
Yeah, if they do, that'd be great. But usually the way I do runtime is like just drawing it out, actually, just step by step, and just saying, okay, this operation here is at order end time, and then combine it with this operation, which is order end time. I get n squared time or something like that.
What I try to do is like based on the examples while creating the examples.
Yeah.
I try to create the order of like how increasing these examples were.
Okay.
Right. But sometimes they were exponential or not. And I was that exactly not exponential, so I'm not 100% sure that's right.
Okay.
So it's kind of confusing to me, but I will put the time.
Okay, I added an entry for whether or not your runtime is correct, so I want you to fill that one out as well. Other than that, I don't need to see the recording right now because I think what we're focused on is good. Just keep the recordings. We'll definitely review them on a later week. But right now, I want to. But most of this is just right now looking and making sure that you're not making any of the mistakes. So, I guess that's it for me. I know I want to give you a time back so that way you can keep practicing this because I know that this is taking you like an hour for each problem or like 50 minutes. But I want to but at this point, the thing we can only hope for is that your instinct basically gets to a very sufficient point. I think you can make it in time for Microsoft, and then dynamic programming might be a killer for you. But I think it's more valuable for us to invest into this. You know what? Actually, how this? Try for this week. Do some dynamic programming from Grokking. Actually, apply this framework that we've been doing, just like for this weekend. Like,
Can I say you? I'm gonna say one thing. I'm gonna tell you one thing.
Yeah.
I was looking to Facebook. Just send me like those general documents about what to expect from the interview process. And there was a line there. There was something like I'm not trusting on this, but if it's a dynamic programming, right? Don't expect any dynamic programming problem, because there's always a solution that will not use dynamic programming. If you want to, I can show you this.
Yeah, they are lowering the bar. They're making it so easy for you guys if you don't have to do dynamic programming.
I can send you the document.
Yeah, send that to me. I'm just like, huh?
Hold up. Yeah.
You guys are
I like read this 3 times. I showed my friend, and no way.
You guys are so spoiled. Oh my god.
Man, it's unfair.
It's not fair. Man, I one of my favorite problems involves dynamic programming, and for you to be able to reason through it. There's no right answer, but it's basically it's a matchmaking algorithm. And I literally asked the people or whoever I'm interviewing to try and implement it. So it's basically given a pool of 10 numbers, find find 2 sets of 5 numbers such that the sum or average, doesn't matter, is as equal as possible, as close to equal as possible. That's a dynamic programming problem. And it's a very fun one because once they answered, then I ask, okay, well, let's say I have a pool of like 10,000 or 1,000,000 numbers, and I want to select 10 such that I can create two, I can create 2 teams of 5. How would you do that? That's where the fun part comes in. And so many people fail that already. Like, most people don't even get past the first part, so.
Hold up, let me just grab this document.
Yeah. I want to read it. I don't understand. I don't believe that they would literally ban dynamic programming like that. Jesus Christ.
Yeah.
So spoiled.
They create a portal, like.
Okay. Yeah, just screenshot it and share it or something.
Hold up.
Yep, no problem.
First round. Oh yeah. There's, I think. Just a minute. DP. Yeah, that's the one.
Okay, let me see. Open up the.
But I think, I don't know, maybe that can be only for the first round. I'll send you the document.
Yeah.
Downloads. I think I'll send you a print actually.
Okay,
because
yeah.
it's getting too much for me to find.
Okay, we can deal with this.
Files.
We can do this on later on. But let's. I would say for now.
No, it's here. I found the document.
Okay, cool.
I found the document exactly in the time. Okay, there we go. Yeah, I sent you on Discord.
Yeah, I got it. Cool. Let's take a look and see what's up.
You can search for DP and you will see exactly the statement there. But there's one thing. This document is only for the first round, but I don't know what to expect for like.
In general, our interviews are 45 minutes of length, consisting of 1 to 2 technical questions. It would pair meta engineer one-on-one, focus on data structures and algorithms. We do not have a preference for coding language. Finally, there will not be any questions that must be answered using dynamic programming. There will be another solution.
I was kind of confusing actually about this statement because
that must be. The question
like,
is must be. Okay, I see. The key word here is must be answered. So which means that if there's a problem that gives you dynamic programming and not dynamic programming, they'll give you they'll probably give you bonus points for dynamic programming. That's the way I'm reading this. It's
better
like,
be prepared.
It's like, yeah, better be prepared. It's like if they'll give you a problem that you can solve without it, but you might get more brownie points if you do get it. And so I want you to at least try giving that a shot for like a weekend. Try to learn dynamic programming for like, a few days up until Tuesday, and then tell me how that goes.
All right. So starting from now, right?
Yeah. See, I want you to give it a shot. Go to Grokking, do dynamic programming, and then try elements of programming interview. I think now with this framework that you got going, it might be easier to understand.
Okay, we'll do it.
All right. Yeah, other than that, I'm going to give you time back and let you go. I know it's been shorter, but again, we're focused on your mistakes more than anything else at this point. So, any questions?
And also, also I'm taking more time actually from a question to other because I'm really deep dive in every question just to what can go wrong or better, just to analyze. So I've been my pace of questions are much lower, but much more detail is happening.
I'd rather you do that. I do notice that yesterday you only spent like 2 hours studying. I think our schedule has you for more.
But no, we schedule 4 hours each day.
Okay.
I've been doing I track my time not only for solving the question, but also studying the question. It's been 3.5 hours all the days.
Got it. Okay, that's fine. This is just the actual solving the problem. The other hour is spent analyzing it.
Yeah, for sure. Yeah, I was aware of this because if you sum up the duration, it is more than 3.5 hours. But more time than this is more me analyzing, and I didn't count in solving the problem.
Okay, that's fine. So definitely do some dynamic programming problems. I think that will help you out. Especially when I noticed that you didn't recognize the LVR traversal and these things. Dynamic program might help. So let's see how that goes. We basically have 2 weeks until, or should I say 10, 12, 2 weeks till Microsoft. So let's do this.
2 weeks.
Dynamic programming for this week. Let's do we'll do a mock interview next week with one dynamic programming problem, one without it. But I'm hoping that by then you will at least get some instinct for the for dynamic programming and for the tests. If we can clear that, I think you have a very good chance of doing very well. Hello? Oh, you can't hear. Okay. Hello?
I can't. No. Yeah, I can hear.
Cool. Yeah.
For instinct 4 something.
So instinct for the tests and what can go right, what can go wrong, before, and look at the problem, and then also the runtime is going to be important as well. If we nail those three, it should be golden for the interviews.
Okay, so I'll keep focus on points you make.
Yeah, like these next 14 days are going to be pretty make or break. So let's hope for the best, and not just hope, but work really hard for it. So, if you have any questions, like all in, right? So if you have any questions, send me the question, or if you need like to chat about something, feel free. I'm always on call, as you know that. So.
Mm-hmm. All right, man. So, and by the way, I keep you posted about Facebook.
Yes, please do.
Anyways.
All right.
Anyways, man. Thanks for the help, and that's it.
Yeah,
Bye.
for sure. All right, talk to you later. All right, cool. So I guess that is... Yeah, I guess that's it. Definitely a big improvement from last time. I think me being very, very strict with him and coming up with that flow sheet for the tests definitely helped. Maybe in the future I should be a little bit more strict and give more solid examples, or at least maybe start off with that, maybe? Yeah, maybe in the future I start off with that. By starting off with like the whole, oh yeah, this is the step you do, this is a test, and all that stuff. But maybe I'll change my methodology in the future. But overall, definitely looking more up. Definitely looking better. I'm hoping that within within the next 14 days, if he does this right, he will gain that instinct for the test of what can go right, what can go wrong. But yeah, thankfully he did come back. Thankfully he did call back, so that was good. And we were able to get a stream in today. So if anyone has any questions, feel free to ask. Otherwise, I'll stop the stream for today. Going once. Going twice. All right. Guess that's it. Yeah. Thank you all for joining me. Sorry about the disconnection and the for the no show earlier, but hope we were able to get him back and we're able to do another stream. So that was good. Yeah. So thank you all for joining me. We will be streaming again next Tuesday, 8 p.m. Pacific Standard Time. We'll be doing much more or less the same thing, looking at the mistakes. I feel like these streams where we look at the mistakes, I'll get a lot more viewer and engagements. So we might stick to more of this style from now on. So hopefully with that, thank you all for joining me, and have a good afternoon or wherever you're at. And I'll see you next time.